Hi guys, this is the third video on K-means clustering algorithm. In video number 1, we saw how we can draw a scatter plot, and we also discussed about various parameters pertaining to scatter plot. In video 2, we discussed how we can calculate the distance between two data points. In this video, we will see how we can form clusters, but we will form only two clusters. So just see this code, how it works. See, we have generated 10 data points like this randomly, and we have also given range. What are these blue and red? These are initially randomly considered centroids. Now, what is a centroid? A centroid is a central location of a given cluster. It will be clear once we run through this program. And these centroids have been created using two data points out of this 10 data points. And those two data points have been randomly selected. Okay, now the next step is, having done that, we will calculate the distance between a given data point and these two centroids. Say for example, consider this data points distance we will calculate between this and this centroid, blue centroid, and then we will calculate the distance between this data point and a red centroid. What will happen? Obviously, it is closer to this. Hence, this will be considered to be belonging to the cluster this blue star is going to represent. So same case for these data points, they will be closer to this. These two, in fact, all these three will be closer to this blue star, right? This centroid. So we are forming two clusters. Obviously, all these will be one cluster, and this will be another cluster. Make no mistake, this and this stars are sitting on two data points. So how many data points are there in this cluster? Let us count. 1, 2, 3, 4, 5, 6, and 7. 1, 2, and here one is there. That is 3. So 7 data points. Correct? So two clusters will be formed, and we will see. And what we will do is we will have different color schemes. So we will color all this as blue and all this as red. Thus we have done that. All blue, red. Now, step number 2. We will reposition this particular centroid after taking average of these blue data points. So obviously it will be pushed somewhere here, and we will take average of these 3 data points, and we will put this centroid at its central location. Now what is this central location? It is nothing but we will take the average of x-axis over here, and we will take average of y-axis of these data points. So we will get some x value, right? Just think that we will get maybe say 6.5 or maybe 7 we will get, okay? And y will be what? maybe 3.75, something like that. So it will come, x will be 7 and y will be 3.75. Somewhere here it will come. I'm just eyeballing it. That may not be the case. And this will again, accordingly, somewhere I'm thinking that maybe here or here. So look at the right side. That is what has happened. And just see, this was sitting on one data point. Now that is visible. And this was sitting in one data point. This is visible. So this graph shows the cluster which has been formed. And this shows the repositioning of these centroids according to the formation of cluster. This is one iteration. Calculation of distance, deciding about the proximity, and once proximity has been decided, just color it and then reposition these centroids. And this we are going to do iteratively. How long? So long as these centroids do not get repositioned, we will continue this process. So let us see the next step. We repositioned it. Yes, repositioning has happened. Correct? Now what happens is, again calculation is taking place. Now when calculation is taking place, see, all these data points continue to be closer to this, and these three continue to be closer to this, which means we need not reposition this centroids, which means average of these three are, this average of these three data points is going to be this only, and the average of these data points is going to be this. Story is done. We will get out of the loop. And if we have to see the data, we can also see this. See, old centroid was 10.43, this one, 10.43x. New one, just see, 10.43. The old, I mean, the old one, like 13, where is my 13? It is 10 and 13, right? It is somewhere here, 10 and 13. This is the first record is about blue. So this is old one and this is new one. The repositioning is not happening. Average of this cluster continues to be this, and average of this continues to be this. We are coming out of the loop. We have formed logically two clusters for those 10 data points. Done? Good. Let us go change the data set and see how it is going to work. Now, this is the time to read this note. See, launch two centroids, nothing but consider two data points randomly selected from the data set to be considered as central locations for two clusters. Just made up centroid. See, this is actual centroid after calculation. This we can say the final centroid. Initially, we had to consider. So we just considered. So these were made up centroids. That is what it is saying. Point number 2. Take the distance between each data point from these two centroids considered. The distance thus calculated will decide a data point's proximity to either of these centroids. So this is what we did, right? Okay. Point number 3, we will calculate the average of all the data points and reposition the centroids to their respective clusters. So we calculated the average and repositioned these centroids to their respective clusters like this. Done? The same thing will happen. So what it is saying? 4. Point numbers 2 and 3, 2 and 3 will iterate. Once the centroids stop changing their positions, we will end the process. So here it was like this and it continues to be like this. We came out of the loop. That means we ended the process. Now we have two clusters in place. Now we can say that, look, our two clusters are like this. Okay, very simple, only two steps to be done iteratively. Great. Now, in the next video, we will discuss about the coding part. Each and every line we will see what exactly each one of them means. But let us change the data set here and just see. Next time what I will do, I will create 5,000 data points, and maybe range I will give, upper range is maybe 250, and let me run this. Okay, oh, these many data points, and randomly these are the centroids, correct? So what will happen? We will calculate the distance. Some of them will get, half of them will get, not exactly half, depending on where they are. Maybe we can think diagonally it will be split, right? This canvas, and this portion will be represented by this centroid, the red centroid, and this will be represented by blue centroid. Just see here. See here. This is our centroid, the blue one, and this is a red one. It is not visible, right? It will be visible only we will have the opposite color. We should make this as red and make this as blue. Then it will make sense, isn't it? It is, blue sitting on top of blue is not making any sense. Though the centroid, this star, has got white edge, but still it is not visible. See, it is uh, getting lost because we have so many data points. No problem. We can even see. See, we discussed that it will be diagonal. So this is first iteration. Now it was lying here, lying here. Now we calculated the average. So this blue is shifting on the right side. Just see here. And red is also shifting right. The first iteration. Second, see, this is second iteration. Again, repositioning is happening. Third iteration. Fourth, fifth, sixth. Look, the line is becoming horizontal. Just see. Let us go to the last piece where we would be coming out of the loop. This is the end of the story. Old centroid, old centroids, this x and y coordinates means they are no more changing their positions. That means cluster formation is done. So we have two clusters in place. See, and check the old centroids coordinates and the new centroids coordinate. What is old and new? Whenever we are recalculating the average of these data point, we are storing the old average, and that we are calling as old centroids. So there will be always two averages, right? Current average. Once we overwrite, before we overwrite current averages, we will copy the current one to the old one, and then we will overwrite. And thus, we have at any given point in time two sets of averages. Okay, so this is how it looks. Done. Good. Let us form, not form. Let us give another data set. Let us create data set like this. Now this time we will give 50,000 and same range. Just see how it looks. How it will look. You know, you have very limited range and 50,000 data points you are going to generate randomly. Many data points will get duplicated, right? Same set of numbers will duplicate because there are so many data points to be generated. Let us see how it looks. Oh, this is how it looks because each and every data point is so close. So they are very close to each other. So you are not seeing dot, You are seeing one flat color. Correct? Now, just see these two centroids we have launched randomly. How it will look? I'm not going to discuss. I will only show the graph, right? I mean, you can make out what is happening. Just see here. This is the position getting repositioned according to their data points. Next step, next step, next step. Continues. Why we are continuing? See, old centroids number. These numbers are different. See, find out 185.59 and here 186.68. There is a very little difference. Hence, we cannot really eyeball the difference between this graph, this graph, and this graph. It's very difficult. They look similar. You can't eyeball, but then we have to go by data. This data set says that they are different, very, very minutely, but they are different. So go to the last stuff and we will see last but one. See, last but one says what? See here difference. 187.97, 187.97, 63.26, 63.25. Any difference, we will continue the loop. Now, once we have drawn this, okay, I said last but one. I should see this one. This one I should see. Okay. Is there any difference? 63.24, 63.23. There is a difference. Now we have come out of the loop. Why we have come out of the loop? We are coming out of the loop because before printing this graph, we are printing this. Now compare this 187.95, 187.95 for the new centroid. 124.77, this is also 1.24. And so will be the case for record number 1. 63.23, 63.23, 126.98, 126.98. So the positions are not changing. We are coming out. Okay, good. Now let us generate another set of number. What that should be? This time we will give something like this. And this will be very interesting piece. Okay, just see. I am giving only 25. This is going to be interesting stuff. Oh, what is this? Look, 5,000 numbers, data points. That is fine. X will be 5,000 and Y will be 5,000. That is fine. But what is the range between 1 and 24? Look, 1 to 24. We have all this scale is done, scaling is done accordingly. So you look at this x-axis. So we have one particular value for x-axis for each data point. So what is happening? Do you think 5,000 data points are there? Yes, but they are overlapping. Many of them are overlapping. But anyway, there are 5,000. Now, how we will form cluster out of this? Same logic. Just see. Randomly it got launched like this. Diagonally it is getting cut. Okay? Fine. Now this see. This was initial position, repositioned according to their own clusters. Again repositioned. And if we cannot eyeball, we should see the data. First we are printing this and then we are showing the graph. So the moment we fail to eyeball, we will go and check these data points. It continues like this. See, slowly the this it is positioned diagonally. Slowly it is becoming horizontal. Done. And what is very interesting about it is sometimes it will be split vertically. How? It depends on initial centroid positions. These are two centroids, right? If they are positioned like this here and here, I mean, there could be horizontal also. See, this is horizontal, right? Yeah, this is horizontal. You can also get vertical. Just see, can we get vertical? We will try. Okay, let us try. Let us generate again. Uh, Let us see. Is it going to happen vertically? Let me see. No, this got finalized like this. This is the final. Oh no, it's coming. Sorry. This is also going horizontally. Okay. So basically, those centroids are initial centroids are getting created randomly. But if we get centroids something like this, mm, let me tell you, here and here, then we can get vertically split. Let me check. Let me run it again. We don't control it. It is happening randomly. So just see what. Okay, let it run. Is it going to happen? Let it run. It is running. Yeah, as expected, this time it is what? Vertical, right? Earlier it was horizontal, now vertical. What is this? It all depends on initial centroid positions. See, now this is vertical. Now we cannot say horizontal is correct and vertical is wrong or the other way around. No, no, no. Depends on what where the positions initially, and the calculation is happening, that it is iterative process, and finally it is deciding, and it is getting split vertically. Correct? I hope this is very clear now, and you must have enjoyed this video. We would go through each and every line of this code in the next video. Thank you for watching.